Okay. Okay, so yesterday, this is our do now, and yesterday we reviewed how to plugged in how to graph, because that's part of what we needed to do today. But we also reviewed then solving systems of equations by graphing. You can get 3 different types of answers with this type of problem. If the lines are parallel, heading in the same direction, like this, what type of solution is it when it looks like this, that they're heading in the same direction? Pretend they're parallel. This is kind of slanted, not quite parallel, but pretend they're parallel. Here, let me try and draw this one a little bit more parallel. There, that looks more parallel. Okay. What type of solution is it when they're parallel lines? No solution, because they never cross. So we use no solution. And then when I have 2 of them that do cross, right, and the solution is the point that they actually cross at. This is the solution right here. Now, if for some reason you graph a line and then you graph another line, but it turns out to be the exact same line on top of each other, this is called infinite solutions, because every single point on that line would work. So then this would be infinite. Okay. We talked about these 3 different solution types. So we're going to graph this first one. And we have y equals 3x minus 4. This is in slope-intercept form. So I'm going to go, my b is a -4. And my slope is 3/4, which means I go up and to the right, unless it doesn't fit on the graph. But I think this one will fit on the graph. So I start at -4. I'm going to go up 3, 1, 2, 3, and then over a +4. 1, 2, 3, 4. And then I'm going to do it again. 1, 2, 3. 1, 2, 3, 4. I keep doing this as much as I can, because you may find out when there's a solution, they'll run it right on to some of the dots you already made. It just makes it easier and more accurate the more dots you make. So now I'm going to graph this other line, which is x equals 4. When it's x equals 4, you go over on the x-axis to 4. And then you're going, like Cora says, you go the opposite direction, right? Then you would think. So it'd be this one right here. So do these lines cross? Yes, it crosses right. It crosses right here. It is a -4. I made a mistake. No, it will cross. You just have to make your line longer. But it should cross at, then it'll be -4 here. Let me move this so that way I can actually see it over here. I have to move this thing out of the way. So if I go down 3 over -4, 1, 2, 3, 1, 2, 3, 4, it would cross right here, because if you extend the line, it'll go through right there. So it's a -4, -8, -4, -8. Any questions on that one? Okay, number 2, both of them are in standard form. When they're in standard form, you are going to have to solve for x first to be able to graph. So I'll use this side to solve for one of them and this side to solve for the other one. So over here you have x minus 4y is equal to 28. You are going to subtract, I'm going to put a 1 in front of the x, so you're going to subtract 1x on both sides. Now, 28 and a negative 1x, those you can't combine together. So you just rewrite it by placing the negative 1x first, and then you'll put plus 28. Now you're going to divide by negative 4 all the way across. So when we go all the way across, we get y equals, and what's a negative divided by a negative?
Positive.
Positive. So I change that to positive 1/4 x. And what's 28 divided by negative 4? Negative 7. So now I'm going to go down a negative 7, make my dot, and I'm going to go up 1/4. 1, 2, 3, 4. Because this is positive, so you go up and over. And I'm going to do it again. Up 1/4. 1, 2, 3, 4. I can go up 1, but I won't have enough room to go over 4. I could go down 1 over negative 4. 1, 2, 3, 4 to get the other side of the graph too. Then I make a nice straight line through a whole graph. Okay, that's that one. Now I'm going to do the other one. And I have 3x plus 4y is equal to 4. I'm going to subtract 3x on both sides. I get negative 3x. Oh, sorry. Let me fix that. I get this cancels. I have 4y here equals. I can't combine these, so you put the negative 3x first. This 4 is positive, so I put a plus 4. I'm going to divide everything by 4. And I get y is equal to 3 and negative 3/4 x plus 1. So I'm going to go up 1, make my dot. From this point, I'm going to go down 3. 1, 2, 3 over a positive 4. 1, 2, 3, 4. Down, and then 1, 2, 3, 4. Down. Uh-oh. I think let's see. We do all this right? Let's see. So negative 4. Up. Negative 4. We subtract that. We had negative 7. Went up. 1, 2, 3, 4. 1, 4. Okay, that one's done right. So we're going to divide this one out. Negative 3x. Did anybody see anything wrong? Let me see what the answer says on the bottom. Let's see if it runs off the graph. Ah, I don't have the answers. I may have the answer on this one. No. Ah, I may have to do that one by hand. Let me try that one again, though. I thought I had the answers. I don't. Oh, I just run the whole thing. Did someone get it something different when they did theirs? You don't know? Let me see. I'm going to just do that one again. Let me pull this up. So yours crossed. Yeah. Let me see. I must have did something wrong. So let me make this bigger. So when we solved, we get x minus 4y is equal to 28. we subtract x, or 1x, and you get negative 4y is equal to negative 1x plus 28. We divide by 4, negative 4. So this was correct. Divide by negative 4. Divide by negative 4. And you get y is equal to, a negative over negative is positive. And you have x. And then this should be minus 7 here. So, oh, I went down negative 5. I didn't go down negative 7. I think I didn't go down far enough when I did mine. I went in between here because I really need to go to the doctor. Up 1 over 4, 1, 2, 3, 4. Up 1, 1, 2, 3, 4. And then that one didn't run off. What were you going to say, Cora? I'm sorry. Yeah, I didn't go down far enough, I think is what happened. I thought I went down negative 5 instead of negative 7. And then the other one, when we solve this one, you subtract 3x. Four y equals negative 3x plus 4, and you divide by 4 all the way across, which was correct on what we did before, which then you get y equals negative 3/4 x plus 1. So 1 is right here. I'm going down 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. There it is, right here. And so when I get that one, it's a it's a positive 8, comma, 1, 2, 3, 4, 5. Okay, that's what we were looking for. And what happened was the other one, I accidentally went here for negative 7. I don't know why I didn't go down there for negative 7. And that threw the whole thing off that first time. Right? Okay. So the next one has point slope form and slope intercept form. So this one's already in slope intercept form. So B is 4. And my slope is a negative 5 over 4. So here I'm going to go up 4, make my dot. From this dot, you're going to go down 5, 1, 2, 3, 4, 5 over positive 4. 1, 2, 3, 4. I think we could do it again. 1, 2, 3, 4, 5. 1, 2, 3, 4. Land right on the edge there. You could also go up 5, 1, 2, 3. Nope, not enough room to go up. So you draw your line. And now I'm going to graph the other one. I'll graph that one in blue. Okay, what is the point when you have it in point slope form here? What's the x value of the point that I'm going to graph first? Do you remember what to do when it's in point slope form? We have to change the signs. So if it's negative, I have to make it positive. If it's positive, I have to make it negative. And the number with the x will be my first number in the parentheses with the x. So it says minus 2. So I write plus 2. Then the one with the y, it says plus 2, but I'm going to write negative 2. You always do that with point slope form. And your slope is 1/2 because that's the number in front right here. So I'm going to graph 2, negative 2, and then use my slope. So 2 negative 2 is right here, right? And then I'm going to go up 1 over 2. And I land right on the line with that first one, which is what? 4. The answer to this is 4, comma, negative 1. Because that's where, if I draw my line, that's where that intersects. Right? And then I just threw, because I have some people who haven't taken their test yet from last week. John, did you take that test on Thursday? Okay, well, sometime you're gonna have to come in and take that. When are you coming in? You can stay after. I leave right at 4:30 though, so make sure you get down here promptly. Okay. Is anybody else staying after to take that quiz? That you missed on Thursday? Or are you coming in on Friday? Okay, so this one is in function notation. When it's in function notation, you are just replacing the 5 with the x and working it out. That's all. And it says find f of 5. That's saying find the value of the output when the input is 5. So I'm going to put 5 everywhere I see an x. This is an exponent, so 5 times 5 is 25 minus 40 plus 12. 25 minus 40, I believe that's a negative 15 plus 12 would equal negative 3. There you go. I just threw that on there, being nice for those who still have to take their test. Okay, so today I'm going to pass out a oh no, that's why I like the little tab. We're going to be graphing linear inequalities. I don't know if you did this with Mr. Steve or not. I think so. I think you just typed regular graphing, but he may have. Yeah, he thought it was no. Oop, I didn't want that. I wanted the so we are on week 3, no, week 4. Yep, we're halfway through. Everybody, yay, we're halfway through. Yeah. So. So we just learned is the thing that was the new curriculum. The graphing inequalities, I mean, systems have always been in the old curriculum for Algebra 1A. The new curriculum for Algebra 1A is actually going to be next week when we start doing elimination and substitution, because that usually has been in Algebra 1B. So I'm teaching that, so then Miss Sarah's Algebra 1B next time won't have that part in there, though. She'll be doing something else with you. Good question, though. So yes, you may have seen this with pre-algebra where we graphed inequalities. An inequality means you have a greater than or less than sign. Now, normally when you solved inequalities, you just solved them and may not have graphed them on a coordinate plane. Or if you graphed them, it may have just been on a number line. Here, we're going to be graphing these on a coordinate plane. When you're graphing on a coordinate plane, if you don't have an equal sign underneath, you're going to use a dotted or dashed line. If it has a line under it, you need to use a solid line. So is this going to be a solid or a dashed line for number one? It's going to be A or B. It's going to be solid because there's a line under it. What about number two? Solid or dotted?
Dotted.
Dotted, yeah. Sometimes I say dashed instead of dotted. Yeah. Okay. Now, choose the inequality symbol for the line. Which one would it be if it's dashed or dotted? Am I going to use this first bubble or would it be the second bubble?
Second bubble.
The second bubble. Okay, we all are cooking with fire now. Because if it has a line under it, it'd be a solid line. With no line under it, we make it dashed. Okay, so where to shade for positive, negative, and zero slopes? So depending on if you have greater than or less than, will determine on which side you shade. Now, when it's greater than, you shade above the line, up. When it's less than, you shade below the line, down. So when you're looking at these, you always want to make sure your Y is on your left side, so that way you're shading correctly. So right here, it says Y is greater than or equal to X minus 2. Notice, this is a greater than sign. Greater than means I shade above the line. Well, if you put your finger on the line, anywhere on the line, and draw an arrow up, that will tell you which side to shade it on because it was greater than, so I got to shade up. Does that make sense? And it was a solid line because you had a line under this. So when you graphed your line, it'd be solid. Make sense? Doesn't make sense? Okay. Now this one had less than or equal to. So in this case, we shaded down. And if I needed to figure out which way down is, I just put my finger on the line, anywhere on the line, and I just go down. This is shading downward. So we're going to graph this one. Before you graph, you want to ask yourself a couple questions. Are you going to shade up or down? You shade up. This is a greater than sign. Because it's like this is greater than. You shade up. You're going to shade up. Now, is it going to be a solid line or is it going to be a dotted line? Dotted. It's going to be dotted because this doesn't have a line under it. And now I'm going to graph using what I know about graphing. I'm going to go up 3, make my dot. 1, 2, 3. I'm going to go down 1 over a positive 2. Down 1, 1, 2. Down 1, 1, 2. Down 1, 1, 2. I make a lot of lines. Okay, and I said dotted. So dotted, I mean you take your pencil and you could still use a ruler to make it nice and neat and just make it more of a dotted shape. Or you could use a pencil and do a solid line and then just erase in between if you really want to. And I said it, and we said we were going to shade up or down. We're going to shade up. So we would shade this way. Whee! Now I have colored pencils. The colored pencils is actually more useful for tomorrow's lesson. But if you want to shade with the colored pencils, you're more than welcome to. And I may need to put some more colored pencils up. Did I go too fast?
No, I'm trying to.
It was, yeah, I think it was the very first graph that we shade on. Okay, so here you're choosing which equation makes sense. So we will cross out any equations that don't have lines under the inequality, correct? Because it has to be a solid line. So this would be a dashed line. This would be a dashed line, right? Am I shading up or down for this one? I'm shading down. Down means less than. So this is the correct equation of the line, because when you shade down, that means less than. Because it's solid, we have a line under it. So it has to be this one. I really didn't even have to look at the line. I could have just looked at the shading, and because the line is solid. Okay, so we good with that? So now I'm going to look here. Well, where are we going to shade for undefined or no slopes? So these are when you have vertical lines and horizontal lines, because there really isn't an up or down. You have a left and right, or, well, the horizontal, you have an up and down. So if the inequality is greater than, we're going to the right of line, because those lines are when you have x equaling a number and x values get bigger going this way on your number line, right? And since it says greater than, then you head where the x's are bigger. If it has less than, then you're going to shade the opposite way. So you'd shade where the numbers are getting smaller. So if I have this one, since this is x is greater than -2, I do my dash line at x is -2, and it's vertical. But because it says greater, I'm going to the right, because the number, your x values get bigger that way. The other way, if it was less than or equal to, this case, because it had a line underneath the inequality, it's solid, but it has less than, your x values get less to the left. Okay? Makes sense? Doesn't make sense? So, is this going to be a solid or dashed line? It's going to be a solid line because you have x is greater than or equal to 3. You go over 3 on the x-axis. 1, 2, 3. You are going to make a solid line. Now, it says greater than. So because it's greater than, which side do the X values get bigger? To the right or to the left? To the right. So I shade this way. Make sense or doesn't make sense? Okay. Use the same algebraic methods for solving equation, except for when you multiply, divide both sides by the same negative. In that case, you switch the direction of the inequality. So if I have it in standard form and I'm trying to solve, I have to make sure I switch the inequality sign whenever you're multiplying or dividing by a negative number. Do you all remember that from pre-algebra? If not, I don't think you took it. I don't know if I reviewed this, but you may, but I'll go over this with you slowly, Adrian, because this is one thing you may have a hole with that jump. Okay, but I think you took pre-algebra elsewhere. Yeah. So we would solve this equation, right? We're going to add 3x to both sides, but 12 and 3x can't be combined. So I put my 3x in the front. But when you divide by a negative across an inequality, Miriam, whenever you divide by a negative across an inequality, you have to flip the inequality sign. See how it went from less than to greater than? It's because you divided by a negative. Somehow you have to remember that. That needs to be big alarm buttons in your head. When I taught middle school, and I would start doing an annoying beep, 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 beep to remind students to go ahead and flip their inequality. When they went to their next class, they scared the teacher, because as soon as they started dividing by a negative, the whole class started going beep, 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 beep. So think about that going in your head. Anytime you divide by a negative number, you have to flip that inequality. Oh yeah, she came and talked to me. She was like, what in the world did you teach your class to do? I said, hey, they didn't forget, did they? Right? Yeah. So I'm here now, and I'm going to graph this. I solve it, and then I graph it. It's in slope-intercept form because I changed it from standard. So before I start graphing, though, I have to ask myself a few things. One, is this going to be a solid or a dashed line? It's going to be dashed. How do I know it's dashed? Because there's not a line under it. So dashed line. Am I going to be shading up, or am I going to be shading down? You're going to be shading up because it's greater than. Anytime it's greater than, when it's facing, you're going to be shading up. When it's less than, you shade down. So I'm going to a -6, right? Here's my -6. And I'm going to then use my slope. My slope is a -3 over 2, which means down 3 over to the right 2. 1, 2. Do I have enough room? I don't know. On your paper, is there not? No. Oh, wait a minute. No, I don't think I have enough. Oh, wait a minute. Oh, yeah. So I'm going to actually have to, I don't have enough room. When that happens, I have to switch these signs around, right? So I'm going to go up 3, and then I have to go this way. So I'm going to go, well, I don't have enough room on my paper. You may have enough room, but I don't have enough room. 1, 2, 3. 1, 2. I think you got to the edge where it could actually go out to the, like, the very last edge mark, but mine got cut off. I could do that again. 1, 2, 3. 1, 2. But yours should look the same direction as mine. and it's dashed. Dashed means it's not solid, so you have to make sure you make it like this. And now I'm going to be shading. And I said I was going to be shading up. So we get all that anxiety out. Cora, you had a rough day yesterday. Use coloring to get all that anxiety out. It actually does help. And color fiercely. Good. Get it out on paper.
You ever been coloring something so pretty and then your kids will be like, "Mom, let me help." And just mess up the whole
Yeah. How are we doing? You good? Paula, are you good? Back there? Thumbs up? Would you give me a thumbs down if you didn't like it? You're good. Okay. Okay, so I'm gonna clear this. I'm gonna look at this one. This is y has to be less than or equal to 4. So this is going to be a horizontal line through 4. You go up on the y-axis, make a dot, and then it's going to go through 4. And it's a solid line because there's a line under it, right? Am I shading below the line or above the line? Below, because it's less than. Less than means I shade below. And the gray, that line here makes it solid. I had a line underneath the inequality. So solid line, now I'm going to shade below. That looks messy. How are we feeling on this? Good? This is more of a review from pre-algebra. Tomorrow, though, we're putting it together. I don't know if you did this in pre-algebra. We will be graphing a systems of inequalities where you would shade using 2 different colors. And you're looking for the intersections where they overlap, because since it's a solution, you want to find all the coordinates that satisfy both equations. And they had 2 more. Do you want me to do the other 2 or just give you time to work on your own? Do you just want me to give you time to work on your own? Just don't forget point slope form, you change your signs. Okay. Let me stop the recording.